acids can have varying concentrations. They can be very concentrated, strong acids, and you might see concentrations that are greater than 1 mole per liter. They could even get higher concentrations like that. You can see hydrochloric acid can have concentrations of up to 12 moles per liter. Sulfuric acid can be as concentrated as 18 moles per liter. So those are quite high concentrations for acids. But on the other end of the scale, we can get very dilute, weak acids that have concentrations around 1.0 times 10 to the negative 6 or negative 5 or negative 7. We could also see things that are basic that even have smaller concentrations of hydronium. They could be in concentrations of 1.0 times 10 to the negative 14 or 15. So the hydronium concentration in acids and bases can vary quite a bit. And the numbers are almost so inconvenient to use to get a really good understanding of the scale and how they compare with one another. Because the numbers can either be really, really, really tiny or relatively big, comparing these two numbers together is not the best thing that we can do to compare acids. So what we use instead is the pH scale, which you are familiar with already. The pH scale is a logarithmic scale, and what the pH scale compares are essentially the exponents that are applied to these numbers, in this case the base of 10, to bring about the concentration that we see here. So I'm going to give you an example. So what are logarithms? When I say the word logarithm, first off, it's got a bit of a weird spelling. That's how you spell it. Logarithm. This is the log button on your calculator. Looks like this. The button just looks like log inside a it's usually the first function on your calculator. And what a log does is it actually tells us what the exponent is inside a power. So for example, I could have something like 4 to the x equal 16. What a logarithm tries to do is it actually tries to tell us and calculate what that exponent would have to be to give us 16. Now in this example, it's really, really simple. We kind of know that x has to be 2. But the way we write this as a logarithm is maybe not so simple. So a logarithm is a little bit like, solving this equation for x. We can't solve this equation for x by addition, multiplication, division, subtraction, reverse order of operations. In order to solve for x here, we actually have to use a logarithm. So the way I write this logarithm is I write log, then I write the base of the power, 4, and then I write the number that 4 is raised to when I apply that exponent of x. So I write it like this: log base 4, 4 is the subscript, 16 is written on the same line, and then x comes after the equal sign. And what this is saying is x is some number that when it's applied to 4, it raises 4 to the larger number here, 16. Now, this number might not always be a larger number. Sometimes it'll be a smaller number, but so I don't want you to confuse you in that regard, but we'll do a couple more examples. So how does this work with the pH scale? Well, the pH scale uses the base of 10. Uses a base of 10. And what we're doing here is we're going to be, a pH is basically looking at the exponent that when it's applied to 10 gives us a concentration, the concentration of hydronium. So for example, water has a concentration of hydronium ions at 25 degrees Celsius of 1.00 times 10 to the negative 7 moles per liter. So what we're actually going to be doing here is when we try to find the pH, first off, we're going to find the logarithm base 10, and we need to figure out what exponent when applied to 10 gives us this number. So for simplicity, I'm just going to rewrite 1.0 times 10 to the negative 7 as an actual decimal number here. So 1, 2, 3, 4, 5, 6. 7. I think that's right. 1, 2, 3, 4, 5, 6, 7. Okay. So once again, what exponent do I need to apply to 10 to get me this number here? Okay. So the answer is going to be minus 7. And you're like, well, how did you figure that out? Well, a lot of this can be done in your calculator. Your calculator already is configured to use base 10. So when you find the log button on your calculator, mine's right there, just find log, and then you just have to input the number. So I'm going to put in the number 1.0 times 10 to the negative 7, and it gives me an answer of minus 7. So the logarithm here, 10, raised to 0.0000001 gives me negative 7. So negative 7 is the exponent that is applied to 10 to give me that number, 0.0000001. Okay, and you may think, like back in math, if you have a negative exponent there, what that really means is 1 over 10 to the positive version of that exponent. So this is like 1 over 10 million. So 1/10,000,000th. So it's a very small concentration of hydronium. So yeah, the 10 raised to the minus 7 gives me this number here. Now it gives me a negative version of that number. So what we do with pH is we actually just take the negative of this. So you'll notice in your reading that pH is actually written as the negative logarithm of base 10 of whatever hydronium concentration I have, like that. And we're going to use this formula pretty consistently throughout the rest of the course. All right, so let's go back and have a look at some of our examples here. What if you had a very concentrated strong acid of 10 moles per liter? What does its pH look like? Well, its pH would equal the negative log base 10 required to give me the hydronium concentration, which is 10. So maybe pause the video here and think about, okay, what exponent would you have if I hide the negative here? What exponent would you have to apply to 10 to give you 10? So the exponent that I need to apply to 10 to give me 10 is really just 1. 10 to the 1 gives me 10. But because I have a negative sign there, what I actually find is my pH is -1, which is kind of a weird one to get. Could pH be negative? Yes, of course it can be negative. You kind of know the pH scale goes from 0 to 14, but you can actually have negative pH values. And negative pH values just tell you that, well, we're getting more and more concentrated in our hydronium levels. What about this one here? If I take the pH of this, I take the negative logarithm, base 10, of the hydronium concentration. So once again, you can put this in your calculator, but if we want to throw the negative in, you need to make sure you press the negative sign. Don't press the subtract sign, press the negative one. So we're going to do negative log. Sorry, I'll just move it there so you can maybe see it a little bit better. 1.0 times 10 to the negative 6. And it gives me the positive version of that value, which gives me a pH of 6. All right, so that's how we calculate pH from the hydronium concentration. Also gives you a little brief overview of logarithms. If you'd like me to kind of expand on this a little bit more, just please let me know, and I can do some more examples. We are going to do some more examples calculating pH from from mass and concentration. So those will be coming up in the next few videos. I'll also talk a little bit about significant digits and how many significant digits I should have in my pH. All right, see you in the next video.